Let's briefly look at the following example. Kristen is on a Ferris wheel in a bucket at the 6 o'clock position and rides the Ferris wheel for one full rotation. The Ferris wheel has a radius of 10 meters, and the center of the Ferris wheel is 15 meters above the ground. We will let D represent Kristen's total distance traveled around the edge of the Ferris wheel in meters, and we'll let H represent Kristen's height above the ground in meters. We know Kristen's height above the ground is a function of her total distance traveled, so we can define a function f to represent this relationship. And therefore, f of d will be equal to h. Now let's also assume the following. Because of safety concerns with boarding the Ferris wheel, the wheel has been lowered so that its center is now 11 meters above the ground. Let's name the relationship between Kristen's height above the ground in meters and her total distance traveled around the edge of the Ferris wheel function g in this new scenario. So in the new scenario, the height of the center of the Ferris wheel is 11 meters above the ground, whereas before it was 15 meters above the ground. So essentially, the Ferris wheel was moved downwards 4 meters, so that the center of the Ferris wheel is now 4 meters below where it originally was. So let's interpret the meaning of this equality. F of 23.6 equals 21. If we look at this equality, we can break it down and understand what each piece represents. The input to the function f is a number of meters traveled around the edge, so this input of 23.6 means Kristen traveled 23.6 meters around the edge of the Ferris wheel. The output of the function f is Kristen's height above the ground in meters, so this output being equal to 22.1 means that Kristen is 22.1 meters above the ground. So if we look at our options, we see Kristen has traveled 23.6 meters around the edge of the Ferris wheel, and she is 22.1 meters above the ground. So this looks good, but the fourth option also says something similar. Now the difference between these two options is the fact that in the first one, we're looking at the new Ferris wheel configuration. In the fourth option, we're looking at the original Ferris wheel configuration. The function f was defined in the original Ferris wheel configuration, so this fourth option should be the correct answer. Now let's determine the value of g of 23.6. And g of 23.6 represents Kristen's height above the ground when she's traveled 23.6 meters around the edge, but in the new Ferris wheel configuration. And in the new configuration, she will always be 4 meters below where she was in the original configuration. So if she's traveled 23.6 meters around the edge, she should be 22.1 meters minus 4 meters. Next question asks us to fill in a table of values. So we've got some values of D in the first column, which represents Kristen's total distance traveled around the edge. F of D represents Kristen's height above the ground in meters for the original Ferris wheel configuration, and G of D represents Kristen's height above the ground in the new Ferris wheel configuration. So if Kristen has traveled 0 meters around the edge, in the original configuration, she's 5 meters above the ground, but in the new one, she's going to be 4 meters below where she was in the original scenario. So in this case, she should be 5 minus 4 meters above the ground. Similarly, if we look at maybe this third entry, if she's traveled 13 meters around the edge, the original configuration, she's 12.3 meters above the ground, but in the new configuration, she's 4 meters lower than that. So in each one of these cases, the third column should just be equal to the second column minus 4, because in the new configuration, she's always 4 meters below where she was in the original. Now, if we take that way of thinking, we should be able to express the output of G in terms of the output of F. we decided that in the new configuration, Kristen's height, which is represented by g of d, is always going to be equal to her height in the original configuration, but minus 4. So in this case, if we take her height above the ground in the original configuration and we subtract 4, that should give us her height in the new configuration. So g of d should be equal to f of d minus 4.